All right, continuing with notes from chapter 5.1, example 4, condensing. So condensing, we are taking these separate log terms and trying to write them as one log expression. So condense 2 bracket ln of x minus ln of x plus 1 minus ln of x minus 1. I'm going to rewrite this to make this a little bit easier to see what properties we need to follow. So between these two terms, I'm going to factor out a negative 1 and then bracket it off and put a plus in between. So now I'm going to take care of this first. Now if you see a plus, ln of a plus ln of b, we can use product property to condense to be ln of a times b. So x plus 1 times x minus 1. This is my a value, this is my b value, plus in between ln of a times b. X plus 1 times x minus 1 gives me x squared minus 1. So ln of x minus ln of x squared minus 1. Now here we can continue condensing, but now we have ln of a minus ln of b, so we can use quotient property. So ln of x over x squared minus 1. Now this 2, we can bring it up as an exponent, so ln of x over x squared minus 1 quantity squared. So now we have condensed our expression to be just one log term. All right, moving on to derivative rule. So the derivative rule for natural log of u is u prime over u. So u represents all the argument that sits inside the natural log function. And u prime simply says find the derivative of everything that is inside the parentheses inside this natural log function divided by the original u value, and then we have our derivative. So example 5, natural log of x, find y prime. So my u value is the x, so the derivative for x is simply, that's the u prime, is 1 all over the original u value. The original u value is x, so 1 over x is our derivative. Example 6, y is equal to natural log of x squared minus 5. So to find y prime, we find the derivative, we do u prime over u. So u prime to x squared minus 5 becomes 2x all over u, which is x squared minus 5. Example 7, anytime we see, this is an example where we want to try and expand and simplify logs before taking the derivative. Just make things a lot easier in terms of finding the derivative later on. So if we can split this up into easier portions, then the derivative process will just be a lot more manageable. So we have ln of a over ln of b. I can expand that. So ln of x squared minus ln of square root of 2x cubed. The square root of 2x cubed, I can rewrite that as ln to the 1/2. So right here, we're going to keep expanding, bring down the 2 in front, bring down the 1/2. So now this is going to be a lot more manageable in terms of derivative rule. So we find the derivative of each term. 2 is the coefficient, so that stays. Ln of x becomes 1 over x. We just apply u prime over u for that expression. The second term, 1/2, we keep that as a coefficient. So the derivative is u prime over u. 2x cubed becomes 6x squared all over 2x cubed. And then we combine this, we get 2 over x minus 3 over 2x. Here the 6 and 2 cancels out with the 2 in the denominator, and then one of the x's cancel out. So we can leave it like this or combine it as common denominator to give us 1 over 2x. All right, couple more examples. Example 8, y equals x ln of x, find y prime. So here you see x and ln x, these are two terms that are being combined by being multiplied. So we have to go through product rule if we want to find the derivative. So we say f prime g plus f g prime. So 1 is the derivative for x, ln of x stays as x, that's the f, and then the g prime, natural log of x becomes 1 over x. We found our derivative. We can clean this up a little bit more, saying this is ln of x plus 1, because x over x reduces to be 1. Okay. Example 9, this is a chain rule example. We have ln of x. So notice this ln of x is the argument for this outer function. So this is not ln times ln of x. This is ln of x. So the way we apply chain rule, we basically just follow this rule here, u prime over u, except now our u prime is this natural log of x. So the derivative for natural log of x is 1 over x. That's the u prime. And then the u is simply whatever is inside the parentheses, which is natural log of x. And we can combine this by moving the natural log of x to the top, sharing that same denominator as the x, making this 1 over x ln x. All right, example 10. ln of xy plus 5x equals 30. Find the derivative. Notice we want to find the derivative of y, but y is stuck inside. This is not a function that is defined as y equals. We have y's mixed in with the x's, so we have to go through implicit differentiation. But first, let's see what we can do to expand, or so we can make our derivative process a little bit easier. So ln of xy, we can expand that using product property. ln of x plus ln of y. Simply, we know the rule ln of ab equals ln of a plus ln of b. We can expand that. The 5x stays, 30 stays. So now the derivative should be a little bit easier to manage. ln of x becomes 1 over x. ln of y becomes 1 over y dy dx. Right? 5x becomes 5. 30 goes to 0. So now we just have to solve for dy dx. So subtract 1 over x from both sides, divide both sides by 1 over y, and when we clean that up, we get negative 5y over, negative 5y minus 5 over minus y over x.